Hello everyone, and in this video we're going to be looking at independent events, tree diagrams for independent events. It's a really nice topic and it's generally answered and understood really well by students. So it's a good one for us to make sure that we've got this. So each morning, so look at the first question. It says each morning Bob and Bill catch the same bus. The probability that Bob catches a bus is 0.9 and for Bill it's 0.7. The probabilities are independent of each other. Okay, so that means that one does not affect the other. Okay, so copy and complete the tree diagram. So the first thing that we need to notice about a tree diagram is that in each branch, the probabilities need to add up to 1. So we've got here is Bob, here is Bill, and we've got catch, and we have got, I'll put NC for not catch. So catch and not catch, catch and not catch. Okay. Now, the probability that Bob catches the bus is 0.9. So therefore, the probability that Bob does not catch the bus is 0.1, because these probabilities need to add up to make 1. Over here for Bill, we have a probability of 0.7 that Bill catches the bus, which means that it is 0.3 that Bill misses the bus. Over here, we've got 0.7 for Bill catching the bus and 0.3 for the missing the bus. And in independent events, we basically just repeat the branches. So whatever we have for this one, we repeat it down here. And one thing that you could think about this is it helped me when I was thinking about this topic, is to imagine these as like different parallel universes, if you will. So what we've got is in this world, both Bob and Bill catch the bus. But in this alternative world, Bob catches it, but Bill misses it, and so on. They're like different kind of like different realities, if you will, or different timelines. So our tree diagram is complete for part A of that first question. Now let's have a look at the next one. So we've got to work out the probability that they both catch the bus. So that's going to be 0.9 times by 0.7. Now, the reason that they're multiplied is because we multiply along the branches. And in probability, when you think about the word and, that means that you're going to multiply. So here we have the probability that Bob catches the bus and Bill catches the bus. So we times along the branches. So that's going to be 0.9 times by 0.7, which is going to be 0.63. So we have 0.63. The next one, it says, what's the probability that Bob catches a bus but not Bill? So Bob catches it, but Bill misses it. So that's this branch. So that's a probability of 0.9 times by 0.3, which is 0.27. Okay, so that's Bob catches it, but Bill does not catch it. Or we could say Bob catches it and Bill misses it, hence the times. Next one, 1, 2, 3. Okay, neither of them catch the bus. So this is Bob does not catch the bus and Bill does not catch the bus. So this is 0.1 times by 0.3, which is 0.03. And then finally, for this question, we have got what is the probability that at least one of them catches the bus? Okay, before I do that, let me just work out the probability for the remaining branch. We know that this one, that they both catch it, is 0.63. We know that this one is 0.27. That's Bob catches it and Bill misses it. And we know the probability that they both miss it is 0.03. So just to complete this, let's now work out the probability that Bob misses it and Bill catches it. That's going to be 0.1 times by 0.7, and that will be 0.07. Now I can check and see whether these are all correct, because this is the entire universe. This is all of the possible outcomes that could conceivably happen. So if we are correct, all of these, when we add them up, should come to 1. So we've got 0.63, add 0.27, add 0.07, add 0.03, and we add all those together, it does come to 1. So we know that these probabilities are correct. Now let's answer this last bit. The probability that at least one of them catches a bus. This is the first bit where students sometimes get a little bit confused. So can we have the first branch where they both catch the bus? Yes, we can, because it says at least one of them. And in that branch, they've both passed. They've both caught the bus. We can have this branch because in this universe, Bob catches it and Bill misses it. So we can have that one. And we can have this one where Bob misses it and Bill catches it. So that's fine. We can have that one. In fact, the only branch we cannot have is where they both miss the bus. So when the question says the probability that at least one of them catches the bus, we're going to say 0.63 add 0.27 add 0.07. Okay. Now, here's an important point. Notice that we're going to be using the word or. In fact, let me write this down. So when we use the word and in probability, we multiply. And when we think about the word or, we add. So in this case, what we're saying is either Bob and Bill catch the bus or Bob catches it and Bill misses it, or Bob misses it and Bill catches it. And because we're using the word or to describe those, we add those probabilities, okay? So you times along the branches, but you add the results at the end. And let's see what that's going to give us. So that gives us our 0.63 add 0.27 add 0.07. Add those together and that is 0.97, okay? So that's the probability that at least one. Now, at this point, and I'm sure some of you have already been thinking about this whilst I've been describing this question, there is another way to work out at least one. You'll notice that there was only one of the branches that we couldn't have. The only branch that we couldn't have was that they both missed the bus. And do you remember we said earlier that all of the probabilities add up to make one? So a quicker way of working out the answer to this last question, part 4, would be to do the following. A quicker way to do this would be, in fact, to do 1 take away the probability that they both miss the bus. And when we work that out, that turns out, again, to give us our 0.97, which was our correct answer. Okay, so that's the alternative way to work out number 4, which is quicker. Instead of working out all 3 of those branches, we just do 1 take away the 1 branch that we can't have. Okay. All right, that's perfect. So that's that first question done. Now, I just want to basically draw your attention whilst we're on this question to a way that they sometimes word this question to make it seem a little bit confusing. So what if they asked us, what is the probability that exactly one catches the bus? Okay, so what's the probability that exactly one of them catches the bus? Now, for some reason, the way that they word that makes it seem a lot more confusing. The probability of exactly one. Well, the way that we're going to work that out is, let's think about it. Exactly one means maybe Bob catches it, but Bill misses it. So that would be this branch. Or it might be that Bob misses the bus and Bill catches it, which is that branch. So when they say the probability of exactly one, what we've got is Bob catches the bus and Bill misses it. So that's 0.9 times by 0.3. And then notice we're saying the word or, so add, Bob misses the bus and Bill catches the bus, which is our 0.1 times by our 0.7. So if they ask you the probability that exactly one of them catches a bus, that's how you would work it out. So we're going to do 0.9 times by 0.3, which is our 0.27, 0.27. And then over here, we've got our 0.07. So we've got 0.27, add our 0.07. We add those together, and that gives us 0.34. Okay, so 0.34 is our probability that exactly one of them catches the bus. Perfect. Okay, well, that is an introduction to how you think about independent events for tree diagrams. Okay, there's another couple of questions there which you could have a look at, and maybe you could have a go at those yourself. I'm going to move on now in the next video to talk about, we're going to talk about dependent events in our next video.